Okay, picking up where we left off, we just finished talking about some of the computer science geekdom stuff. So back to the textbook, on page 314, they talk about the benefits. So it helps the host know if the destination is local. So one of the things the host can do is say if the person I'm talking to is local or not, then I can kind of cut the crap and just talk directly to that machine. It's kind of sort of simple. So I compare the IP address I'm sending to and the IP address that I've got for me, and I want to determine if they're on the same network. So the subnet mask will zero out everything except for the subnet. I'm sorry. Let me start over. It will zero out everything except for the network. And so I perform that operation on the destination and on mine. And then all I have is the naked network over here and the naked network over here, and I just compare the two. It's kind of simple. So if they're equal, then I'm local. And then I just do normal traffic, which would be an ARP request to find out how to talk to that machine, because I know the ARP will work because it's on the same subnet. And then I just proceed to send the packet to the guy. If, on the other hand, I strip out the host part so I have a naked network and a naked network, and they are not the same, then I know that there's no way I can reach that machine through normal techniques, and I must use a router. Most people have just a single default router, which basically means if I don't know how to get there, I'll just pass it to you and have you figure it out. That's the way most people have the routers. This is not a complex course where we're going to go into alternates of that, but just trust me, there are other ways. But essentially, if it's local, I'll do my thing. If it's not local, I'll pass it up to the router and ask the router to do its part. Okay. So let's talk the scenarios one more time. Let's say I have 4 or 5 hosts that transfer an awful lot of information among themselves, and they are consuming one heck of a lot of bandwidth because those guys are very chatty. They talk to each other a lot. So once again, I'd probably want to put those in their separate subnet so I wouldn't have to route between them, because routing is slow-ish and it takes a lot of energy. In other words, I have to send it to the router. The router has to, take the packet, figure out how to route it, and then send it back along. So there's a delay, and because remember the store and forward model, I send it up and it has to sit in the router temporarily until the entire packet is complete, and then it sends it back on the wire. So right off the bat, I'm incurring some delays. So whenever I have 2 machines that talk to each other a lot, I don't want to send them through a router. I mean, you could, but if you want to go for an optimal design, you probably want to eliminate that router in between if at all possible. So obviously, putting them in the same subnet means you do not have to go through a router to get to them. Does that kind of sound like a test question to you guys? Okay, just checking. All right. So what does the router need to know? Does the router, this guy over here, I'm going to close some of these goofy windows. Does this router here, does he have to know what the subnets are on these guys? Does he need to know that? Yeah. Because I'm sending a packet in, he has to be able to say, well, here are my networks. Because, again, whether it's a legitimate network part that was sent to you by the IP address naming authorities, or the network part is something that you tacked on. You stole a few bits from the host part and tacked on and made your own network part. It doesn't really matter. Your machines have to know. Your routers have to know where those network parts are. Now, what happens if you have a misconfigured machine? Let's say you have a gazillion machines like this, and some poor silly machine down here accidentally got the wrong subnet mask. Okay? Let's say you got one with no subnet mask whatsoever. So he thinks that he's talking to a Class B network. That's what he thinks he's doing. So he says, well, I need to talk to Bob over here because, hey, he thinks he's a Class B. And he just broadcast it out. He says, hey, where's Bob? So he's going to do an ARP request for Bob, which is not going to work because you can't do an ARP request through a router. And so you'll never talk. Now let's think about what happens if you do it the other way. Let's say, for example, I misconfigured my subnet mask. Instead of having a /21, I typoed it in, and I accidentally typed in /24. I made a mistake. Dang it. So now I want to talk from this machine over here to another machine on the same subnet. However, my machine is misconfigured, so it thinks it needs to go through the router. It doesn't, but it doesn't know that. It's going to send the packet to the router. Please forward this to Bob. Is the router, here's a good question, is the router going to say, well, that's stupid, do it yourself? Or is it going to say, well, okay, I'll go ahead and forward it to Bob, even though this is dumb? So it is going to honor the request. You can actually send a request to a router and say, please route to my own network. I mean, that sounds dumb, but it will do it. It will say, okay, dude, now what you should be doing is checking these routers to see if there's any misconfigured routing going on like that. Because, go into the router and ask the router, how many times did you route things that you didn't need to route? And it'll come back and tell you. And then you go, oh, they're all coming from this machine over here. Let me go check the subnet mask on that machine. I bet it's wrong. So in one case, if it's pessimistically configured, you won't talk to anybody outside your own little area. If it's optimistically configured, it'll work, but it'll be kind of slow and kind of annoying. Okay, kind of makes sense? Okay. So let's talk about IPv6, because that's kind of where we are in the world. Now, in IPv4, you basically had the network part that was provided to you. Then you had the host part, which you could carve out a few bits and kind of move things around to make your network part look bigger if you wanted to. All right. In IPv6, we don't have to steal from one section to make it, because we have plenty of network. We have plenty of numbers, lots of bits. I don't have to steal from the network part. I don't have to steal from the host part. We just don't need that anymore. So here's how it is. We have 48 bits in what they call the global routing prefix. Okay, let's just call that the network. Okay, so that's the network part. And we have the interface, which is 64 bits. Let's just call that the host part if we're trying to compare the two. So the hosts. By the way, 64-bit is big number for a host. And they wanted a big number because they wanted to be able to grab the 48-bit MAC address and throw it in there and have a few extra areas to mess with for doing multicasts. But anyway, back to the story. So I have 16 bits here that I can use as a subnet. Now, this is not a subnet mask, because if it was a subnet mask, that means I would only have 16 possible subnets. Ew, that sounds bad. This is a subnet ID, because I don't have to have a mask anymore because I'm not doing that. It's just a number. So essentially, I have 64,000. So everyone who has an IPv6 gets automatically the ability to have 64,000 subnets for every single one of their networks that are provided to them. Kind of cool. So no robbing Pete. How's that saying go? Robbing Peter to pay Paul? Yeah, robbing Peter to pay Paul kind of a thing to make the network part grow and shrink. Here, I got enough room. I don't have to steal from anyone, and I have 64,000 different options for the subnets. Isn't that pretty cool? Okay. So, the idea is the same. The need for subnetting is identical in an IPv4 and an IPv6 scenario. The needs are the same. And we've kind of been through that. It could be geography. It could be traffic. It could be organizational. It could be security. It could be lots of different reasons why you want to do subnetting. So the reason for doing it is the same. The only thing that's really different is the mechanics. Instead of having to go in and carve off a few bits and do some funky stuff, I just use one of these guys. And I'm just starting it, since there's nothing strange, I just start with 1, go to 2, 3, 4, 5, however many I want. Cool? Okay. So it has built-in support for subnetting. Woohoo! Okay, we have reached the end of the chapter. And I'll see you guys again in some future chapter.